Suppose we'd like to write a program fragment that checks whether a variable contains a valid GPA. A GPA, or grade point average, is a number that must be between 0 and 4. We want our program to correctly print a valid or not valid message. Here are two conditions that need to be true for the GPA to be valid. First, it must be at least 0, and second, it must be at most 4. We're including both 0 and 4 as legal values. If the GPA is at least 0 and at most 4, then we know that the GPA is valid. Otherwise, it is invalid. You might guess that we'd use an if statement to encode this logic. But the if statements that we've seen so far can evaluate only a single condition. X is less than Y, for example, or X is greater than Y. And our GPA example needs two conditions. GPA is greater than or equal to 0, and GPA is less than or equal to 4. We'll introduce a new operator to help us here. This operator, two and signs, is the logical and operator. Logical and connects two expressions, and the resulting compound expression is true when the expressions on the left and the right are both true. Let's use logical and to write the GPA example. In this line, we declare a float variable called GPA and give it an initial value of 2.3, a valid GPA. We will change this number later to an invalid GPA to further test our program. This if statement uses the logical and operator that we just introduced. It includes two conditions, that the GPA is greater than or equal to 0, and that the GPA is less than or equal to 4. Both of these conditions must be true for the GPA is valid message to be printed. In all other cases, that is, when one of the conditions is not true, then the GPA is not valid message gets printed. Let's try it. Notice that we get the success message. Let's change the 2.3 GPA to an invalid GPA. Let's try a GPA of 5.0. Now, as expected, we get the invalid message. Here's a different problem. Imagine that we have two GPAs and we want to determine whether one or both of the GPAs is at least 3.0. We have two conditions again, that the first GPA is at least 3.0 and that the second GPA is at least 3.0. But logical and is not the correct operator to use here. If we used it, then we'd be checking that both GPAs are at least 3.0. But that isn't what we want. It would exclude, for example, the case where the first GPA is 3.5 and the second GPA is 2.0. What we want this time is an operator that lets code run if the first condition or the second condition or both conditions is true. And this new operator is written like this, as two vertical bars. It's called the logical OR operator. We see this operator in practice to detect whether one or both GPAs are at least 3.0. These lines declare and initialize two variables to hold our GPAs. We've chosen 2.2 and 3.3 here. Notice that the first is at least 3.0, but the second is not. And here we use the logical OR operator. We can understand this operator as saying when GPA 1 is greater than or equal to 3.0, or GPA 2 is greater than or equal to 3.0, then the entire condition is true. Otherwise, it is false. This if statement will print the first message if one or both GPAs is at least 3.0. Otherwise, it will print the second message. If we run the program now with GPAs 2.2 and 3.3, then we see that the correct message is printed. Now let's change 2.3 to 1.3. So now both GPAs are under 3. If we run the program now, we see that the else branch has executed to once again print an accurate message. There's one more operator that we'd like to introduce here. It's called the NOT operator. It can come in handy depending on how we think about the conditions for a given problem. For example, let's go back to our earlier task of determining whether a GPA is valid. Here's an alternate way to think about this problem. Rather than determining when a GPA is valid, we could instead determine when a GPA is invalid. A GPA is invalid if it is less than 0, or or greater than 4. To get a valid GPA then, all we have to do is negate this condition. Whenever a GPA is not invalid, then it's valid. We can write this using the not operator. Here's our new if condition. We use the not operator, the exclamation mark, to negate the condition of a GPA being invalid. That gives us an alternate way of thinking about GPA being valid. We've now introduced 3 operators: logical and, logical or, and not. These are called Boolean or logical operators. One way to remember how these operators work is through their truth tables. Let's look at the truth table for and. This line is saying that if expression 1 is true and expression 2 is true, then the expression 1 and expression 2 will be true. In fact, that's the only situation where the expression will be true. If either of the operands are false, or if they are both false, the result of a logical and will be false. Compare that to the truth table for logical or, where we see that the rightmost column is true when we have at least one operand true. The truth table for not is simpler because it takes only one expression. It simply negates the truth value of the expression from false to true or vice versa. These new logical operators contrast with the kind of operators you saw in the previous video. These operators, for example, less than or equal to, are called relational operators because they relate or compare 2 items to determine whether something is true or false. The operators in this video are called logical operators. They allow us to combine multiple conditions in various ways.